Hi everyone, I am Dr. Millie and you are watching Erudite Chemistry, and today's topic is hydride. Hydride, IDE, it's a suffix we can see in this name. Hydride means this IDE most of the time in chemistry what we see when there is negative ion. We use the IDE suffix for it. You know that? Chloride, fluoride, bromide, iodide, oxide, hydride, hydroxide. Many of the ions are there when they are negative in nature, when ions are negative in nature. But here this is a common term given for the compounds made by the elements with hydrogen. So don't get confused that you will not get always that hydrogen is in hydride form here. So you will not see here that hydrogen is always in this form, but the compounds made by the different elements with hydrogen, and these compounds are binary compounds, means only hydrogen and that element will be there. So these binary compounds made by the other elements with hydrogen are called hydrides. Okay, so these hydrides are very important compounds, and we have divided them into three categories. The first category is ionic hydrides. These ionic hydrides are also named as saline hydrides. We will be discussing the properties later on. First of all, we will see what type of hydrides are there. First is ionic, second is covalent or molecular hydrides. Third is interstitial or metallic hydrides. So we have three type of hydrides at all, that is ionic hydrides, covalent hydrides and interstitial or metallic hydride. One by one we will be understanding the properties of all type of hydrides. So I am taking first of all ionic hydrides. We will see what type of elements make ionic hydrides, what are the properties of these ionic hydrides, and many more about the ionic hydrides. So let us start with ionic hydride. The very first thing which we have to understand here is the S block element make ionic hydride. S block elements, we have how many groups are there in S block? There is group 1 and group 2. So the elements of group 1 and the elements of the group 2 makes ionic hydride. We know that these elements are electropositive. These are highly ionic in nature, like they have tendency to lose one electron so that they can make positive ions. That is why this is possible for these elements, like sodium can lose the electron and this can make hydrogen to gain the electron so that they can turn into minus ion. So that makes Na plus kind of compound. These are sodium hydride. Technically this is hydride here. Okay, next is suppose it is magnesium, that can form magnesium hydride. Formula will be different because magnesium is having 2 valency and this is 1 electron losing and this is 2 electron it is losing. Same way all the elements of this first group and second group make the hydride easily. On the other hand side, these type of hydrides are ionic in nature. We are categorizing them as ionic hydride because complete transfer of electron is taking place here. But there are few hydrides. What are they? These are lithium hydride, magnesium hydride and beryllium hydride. We know that these elements are very small in size, and just because they are small, their ionization enthalpy is very high, and this is the reason that they do not form ionic hydride. The compounds which are formed by the small elements in the first and second group are covalent in nature. So the same way, this is the reason that these three do not form ionic hydride. These hydrides को छोड़ दें, we leave these hydrides. इसके अलावा बाकी सारे hydrides made up by the first group and second group elements are ionic in nature. ये कैसे हैं? Covalent. ये सारे hydrides are covalent in nature, except that all the hydrides are ionic in nature. ठीक है? So this is hydride, ionic hydride, and obviously because their hydrides are ionic in nature, what will be the general characteristic shown by them? That they will be crystalline in nature, they will be hard, they will be having high melting point, having high boiling point. These characteristics will be shown by them. Apart from that, when we move up to down in a particular group, hydrides of the particular group. For an example, if I see the hydrides like sodium hydride, potassium hydride, rubidium hydride, cesium hydride, what you can see here, the stability of the hydride decreases up to down. What is the reason behind? Stability decreases up to down. The reason is the size of atom with which it is forming hydride. We know this thing that this is sodium and this is hydrogen. The size of the hydrogen is very small. Sodium can hold it easily, but the overlapping between these two is not that good. That is why they becomes when you heat them, the thermal stability decreases up to down, because if we reach about the cesium, up to the cesium, the size of the cesium is very big. So the overlapping is not that strong between the cesium and hydrogen. That is why the stability of the hydride decreases when we move up to down because of increase in size. And just because all of them are crystalline in nature, ionic in nature, they will conduct the electricity also. These are the general properties made by them. If we electrolyze their hydride, what will happen? Means if we pass the electricity through their hydrides, obviously the hydrogen will make hydride minus ion, and just because it will make minus ion, it will go to the anode. So if I pass the electricity through it, so on electrolysis, what will happen? Sodium will give Na plus and hydrogen will make H minus, and minus will go to the plus, plus will go to the minus, and this hydrogen will go to anode, which is positive, and at the anode it will convert into hydrogen. So on electrolyzing, hydrogen will be obtained at anode. So it's very simple, hydrogen will be obtained at anode. If you heat them, क्या होगा? The stability, as I have told you, on heating, they will break down because the stability decreases up to down. तो जो नीचे वाले एलिमेंट्स के हाइड्राइड हैं वो इजीली टूट जाएंगे, जो ऊपर वाले एलिमेंट्स के हाइड्राइड्स हैं वो उतना आसानी से नहीं टूटेंगे. So the stability decreases up to down of their hydrides. Okay, और क्योंकि they on breaking, on heating, on decomposing, they give the hydrogen. They are used as a solid fuel. हम इन्हें solid fuel की तरह use कर सकते हैं because they provide us hydrogen when it is needed. Okay. Now let's talk more about the hydrides. What is that? As I told you that these hydrides are also known as saline hydrides, isn't it? Saline hydrides. Saline means like it's from salty. Salty means salt-like. Salt-like. Why they are known as saline hydride? The simple reason is that their structure, crystalline structure, resembles with the structure of sodium chloride, which is the salt present in sea. That is why they are also named as saline hydride. Okay, next important thing is that the melting point and the boiling point of these hydrides also decreases up to down in a particular group. Why? Because of the bad packing efficiency. These are bigger in size up to down, where we know that the size is increasing, and just because their size are more, the packing of the crystal is bad, and that is the reason that their melting point decreases up to down when we move in a group. Okay, apart from that, there some properties are there that whenever I react these hydrides, like अगर मैं lithium hydride को react कराती हूँ with other type of compounds, like suppose I am taking AlCl3 here. So if I am reacting lithium hydride with the aluminum chloride, I will get a very good reducing agent. What they are? LiAlH4. This lithium aluminum hydride is a very good reducing agent. Reducing agent which easily provide hydrogen. These hydrides easily form special reducing agent by reacting with other compounds. One more example is there, very common, and that is sodium hydride. अगर मैं इसको react कराती हूँ with B2H6, NaBH4 will be formed. The name of this compound is sodium borohydride. This is again a very good reducing agent. There is maybe very good amount of hydrogen is present. Whenever it is needed, it is going to give you hydrogen. So this is lithium aluminum hydride, this is sodium boron hydride, and these are the reducing agent which can be utilized as for the reduction of other elements, other compounds, not elements. So these are the very good reducing agent. Whenever it is required, they can be utilized. So these are the general properties of ionic hydrides. Now let's talk about the another kind of hydrides, and they are covalent hydrides or molecular hydrides. Covalent and molecular hydrides, obviously there will be no H minus ion, and they are very common, important also, and we have seen them, covalent hydrides. As the name is indicating, it is going to connect with the covalent bond. So by the sharing, so there will be no charge. What type of, this is further divided into three categories. I am starting from first category is electron precise hydride. Electron precise hydrides, the name is indicating कि जितना electron इनको चाहिए था, they have that much amount of electron. Means they satisfy the octet rule. They have the number of electron which they want according to the octet rule. So these hydrides are those in which the number of electron are sufficient enough to make them stabilize. So they are electron precise hydrides. Another kind of covalent hydrides are electron rich hydrides. And the next type is electron deficient hydride. One by one we will be talking about all of them: electron deficient, electron precise, and electron rich hydrides. First thing is electron precise hydride. The very good example is CH4, SiH4. Okay, all of you know that what is carbon? C. What is the configuration of the carbon? 1s2, 2s2, 2p2. How many electrons are there in the outermost shell of the carbon? This is 1, 2, 3 and 4. And just because it is combining here with the 4 hydrogen, we know that covalent bond is formed between the hydrogen and carbon in the 4 directions this way. And just because hydrogen and carbon both are satisfied in this compound, that is why this type of species, these type of hydrides made by the carbon with hydrogen is called electron precise hydride, and these are covalently bonded, and that is why they are categorized in covalent hydrides. Are you getting this point? That these are justifying the octet rule, so they are satisfied compound. On the other hand side, we have electron rich hydrides also. In electron rich hydrides, a very good example is NH3, H2O, we have H2S, we have H2, HCl. Basically, the elements of the groups 15, 16 and 17. So these group elements have tendency to form these kind of hydrides. What is the nature of these hydrides? These hydrides, like look at the nitrogen, 1, 2, 3, 4, 5 electrons. 5 electrons are there in the nitrogen. So they will combine with the hydrogen to form hydrides this way. That is, the hydrogen is satisfied, the nitrogen is satisfied, but they are showing the octet rule also, they are satisfying the octet rule also, they have same number of electrons which are required by as per the octet rule. But one thing is important here, that this is not involved in the covalent bonding. This is not involved in the bonding, so this can be shared to the needy atoms. That is why they have tendency to donate these electrons. Donate these lone pair of electron, and just because they have tendency to donate these lone pair of electrons, and they have extra electrons basically which can be donated to the other element, that is why these are called electron rich hydride. And just because they donate, they are the donors, and the donors of electrons are called Lewis base. Hence electron rich hydrides, always remember, electron rich hydrides work as Lewis bases. So you don't forget that electron rich hydrides have some extra electron which can be donated as a lone pair, and that is why these hydrides are electron rich hydrides. And the next type of hydrides, covalent type of hydrides, are electron deficient hydride. Electron deficient hydride, as the name is indicating, they will not be following octet rule, means they will have number of electrons less than required. So इनमें number of electrons कम होंगे. Let's see what group elements make these hydrides. 13 group elements. Remember that aluminium, we have boron. So these aluminium boron kind of elements make these hydrides. Let me give you one example. Aluminium having 3 electrons in its outermost shell. When it will form AlH3, what it will form? AlH3. It will combine with the 3 hydrogen to form the hydride. Okay, but when it form hydride, outermost shell of the aluminium will contain only 6 electrons, but it needs 8 to get satisfied. That is why it has tendency to attract the lone pair of electron, and this is the reason they work as a lone pair acceptors. Lone pair acceptors, and this is the reason that these electron deficient hydrides work as Lewis acid, because we know that acceptors of electron in chemistry are called acid. So do remember, Lewis acids are electron pair acceptors, and just because they are accepting, the reason behind is that they are deficient, and that is why they come in category of covalent hydride electron deficient type. I hope it is clear to you. A very good example is AlH3, BH3, AlH3 and BH3. Just because they are not existing as AlH3, because इनका outermost shell complete नहीं है, तो कैसे exist करेंगे? They will form dimers where two of the molecule AlH3 या BH3 के 2 molecule combine करते हैं to satisfy themselves. For an example, AlH3, another AlH3, but this H and this H is supporting aluminium. Actually, there is a bond between these two. इस तरीके से में bond exist करता है, which is also called banana bond, and this is stabilize the electron. That is called, this is stabilizing the structure. These two combine to form a single compound, and it is Al2H6. Actually, it is AlH3, but it exists as Al2H6. Now let's talk about the last type of hydrides, and it is metallic hydride or interstitial hydrides. Interstitial or metallic hydrides, they are non-stoichiometric in nature, means they will not show a particular formula of their hydride. Just like calcium का hydride was CaH2, magnesium का hydride was MgH2, aluminum का hydride was AlH3, like that. They do not show stoichiometry coefficient. It's not fixed. Proportion is not fixed. And in these particular hydrides, what happens is, in the crystal lattice, when there are, we know that the gaps are there between the atoms and atoms, interstitial gaps. In these interstitial gaps, these hydrogen atoms are found, and nobody knows that how they are connected with the metal, but they are found in the interstitial spaces. That is why these hydrides are known as interstitial hydrides. ठीक है? First of all, let's talk about कि कौन से metals make these hydrides. So do remember, D block element, which are typical metals, form these hydrides. So I am writing down here D block elements. Okay, not to forget D block elements. All we know that D block is starting from 3rd group to 12th group. Okay, so 3rd group to 12th group, all the elements except, to remember, group number 7, group number 8 and group number 9. These 3 groups do not form metallic, these type of metallic or interstitial hydrides, and this is called hydride gap. So if it is asked what do you mean by the hydride gap, the group of 7, 8 and 9 elements do not form hydrides with the hydrogen, and that this gap of the from the making of hydride is known as hydride gap in the table. Apart from that, one more group is there, that is 6th group. In 6th group mein only chromium is there. Only chromium is there, which makes hydride. Rest of the elements do not form hydrides. Okay. Otherwise, In the D block, all the elements from the 3rd to 12th make the hydrides. Second important thing is, as I have told you, they do not show a particular stoichiometry, मतलब इनका ratio change हो सकता है. So if I write down the formula of lanthanum hydride, the lanthanum hydride is LaH 2.87. On the other hand side, if I write down the zirconium hydride, ZrH, तो 1.3 से लेके 1.75. The ratio is changing, you can see there. If the ratio is changing, they are not showing the particular stoichiometry. Just like metals, they are good conductors. Their density is lower than the metal. क्यों हो जाती है? क्योंकि हाइड्रोजन को ऑक्यूपाई करने के लिए थोड़ा सा ये एक्सपेंड होते हैं. तो the density is somewhat lower, but they are good metals. They are good. Their conductivity is good. So the general properties of the metal do not change. So this is all about hydrides. Hydrides, 3 type of hydrides we have learned, that is ionic hydrides, covalent hydrides and metallic hydrides. Ionic hydrides made by S block element, covalent hydride made by P block element except 18th group, and these type of hydrides made by D block element, which are typical metal in nature. Typical metal है इसलिए इनका lattice है, इसमें जाके इनकी interstitial spaces में these hydrogen atoms are found. So this is all about hydrides. If you like this video, please hit the like button and share it.